Hi, guys. This is Mrs. Homer, and today we're going to go over how to interpret a cladogram. We've learned that phylogeny is basically evolutionary history. And one way to see phylogeny is by looking at a cladogram. So, this is a picture of a cladogram. This is a traditional one in the middle that we're going to be looking at a lot. Cladograms are just diagrams that show evolutionary history. So, they show the phylogeny for a set of organisms. And so by learning how to read a cladogram, you can understand how these organisms are related and how they evolved. So the first thing you have to understand when you go to read a cladogram is that it's basically a timeline. And so you have to understand where current time is and where the cladogram began. So, for the traditional cladogram, the organisms are listed at the top, and that is where current time is. So, if the organism made it all the way to the top, it is an organism that is currently alive in present day. So, then to find the actual timeline, we're going to look at the backbone of the cladogram where the animals are not listed. So, this line right here is my backbone, and I'm going to start at the bottom left. This would be the oldest ancestor here down at the bottom and the furthest back in time. So, this is my starting point. Then, as I travel up this cladogram, I get more and more current. So, if I look at this, species one evolved off the branch first, then species two evolved. And lastly, species three and four evolved together. And I say that because they branched off at the same point. So we say three and four happened around the same time. Go ahead and take a minute to answer these questions about the cladogram as a timeline. So the first question, which species has been around the longest, would be the lancelet because it's starting down here at the bottom. This is my starting point. The lancelet breaks off first. And then which two species have evolved most recently? That would be the leopard and the turtle because they branch off the last part of my cladogram. All right. No other thing I want to point out is that sometimes a cladogram will be drawn a little differently. This one, the cladogram is turned on its side, and the animals are listed where these boxes are. Well, you still figure the timeline out the same way. So I find my starting point here on the backbone. And now, as I travel down the backbone, I'm getting to more and more current time. So this is oldest at my starting point, the youngest down here. And so the first organism that evolved did so at A, it branched off. And so when you go and you're looking at a cladogram that looks a little different, always try to find that starting point and understand how the time is progressing in your picture. Okay, so two things you're going to have to know about cladograms are the nodes and the derived characteristics. So we're going to look at nodes first. So along the backbone, you'll notice that these species branch off at different points. And at each one of the places where they branch off, I've listed it as a number 1, 2, 3, 4, 5. Well, that spot where there's a branch off is called a node. And a node represents a common ancestor for any species that comes after that point. So, for instance, number four is a node. It's a common ancestor to any organism that comes after it, including the salamander, the turtle, and the leopard. The higher the node, the more recent the ancestor was. So, the more recently it evolved. And the higher the node, the more DNA and the more characteristics those organisms will share. So, for example, the turtle and the leopard share a common ancestor at node number 5. The tuna and the leopard show a common ancestor at node number 3. Well, because 5 is higher than 3, 5 is a more recent common ancestor. So the turtle and the leopard are more closely related than the tuna and the leopard. And as a result, they'll share more characteristics in common as well as more DNA in common. But take a minute to answer these questions on nodes. All right, the first question: which node is the oldest common ancestor? So that would be node number one. So all the way down here at starting time, that would be the oldest common ancestor. Question two: which node represents the common ancestor of salamanders and leopards? Well, take salamanders, follow it down, and see where it matches where leopards is. So I follow leopards down, and the number would be four. So node number four represents the common ancestor of salamanders and leopards. What species are linked by the common ancestor found at three? Well, anything after three is linked by this common ancestor. So that would include the tuna, the salamander, the turtle, and the leopard. And then, which two species are the most related? Salamanders and turtles, or turtles and leopards? Well, salamanders and turtles have a common ancestor at number four, where turtles and leopards have a common ancestor at five. So the turtle is more related to the leopard. They share a higher node and a more recent common ancestor. So a turtle will actually have more DNA in common with a leopard than it would with the salamander. All right. The next thing we want to look at are the characteristics that are listed on this cladogram. And so any trait that evolves as these species are branching off are called derived characteristics. And they're just traits that we see kind of appear as time progresses. And any organism that comes after the trait listed on the cladogram will have that particular trait. One thing I like to do to know what traits an organism has is just to start at its name and then follow the path back in time. So if I start at the salamander, I go to my backbone and then go back in time. The salamander has four walking legs, jaws, and a vertebral column. So that's one way you can figure out what characteristics an organism has. The other way to look at it is that everything that comes after the characteristic has that characteristic. So everything that comes after jaws, that would include tuna, salamander, turtle, and leopard, has jaws. Be careful. For instance, up here, the leopard has hair, but the turtle does not. So sometimes you'll see traits on these branches, and those traits would apply only to the organisms off those branches. So again, here's the tuna. Tuna has jaws, a vertebral column, whereas the turtle has a shell, amniotic egg, four walking legs, jaws, and a vertebral column. So take a minute to answer these questions on traits. So which organisms have hair? It would be just leopards. That's the only one that comes after hair. Which organisms have a shell? Just turtles, because that's the only thing that comes after the shell. What organisms have four walking legs? Well, everything after four walking legs would be the salamander, the turtle, and the leopard. Do lampreys have jaws? No. Lampreys branch off before jaws, so they do not have jaws. And then lastly, what traits do salamander and tuna share? So to figure that one out, you had to find their common ancestor. And so their common ancestor between the tuna and the salamander is at node three. And so everything before that common ancestor they have in common, which would be jaws and a vertebral column. That's because notice the tuna doesn't have four walking legs. So it can't share that in common with the salamander. All right. One last thing is that cladograms are going to look very different sometimes. And so again, just remember to look at where it starts and then start to see where do things branch off along the way. And uh, understand that when we build a cladogram, that DNA is always going to be the best evidence to build our cladograms with. And so you can see before and after these two cladograms look very different. And that's because we introduced DNA evidence, which told us more about the phylogeny, the evolutionary history, and helped us build a um, better cladogram. So cladograms are always changing, and as we get to know more and more about the DNA of organisms and the proteins they share, we'll be able to improve our cladograms and our tree of life. All right, that's all I have for you today. The next time we'll be looking at building cladograms. So enjoy the rest of your day.